Okay, today guys, we are going to be converting from rectangular to polar coordinates, and we're going to be working some with equations. So in the previous video we converted from polar to rectangular. Now we're going to convert from rectangular to polar, and you'll need to know two more equations, two more formulas for how to do this. You'll need to remember that the tangent of theta is y over x, and you'll need to remember that the radius squared is equal to the x squared plus the y squared. So that makes a total of 4 formulas so far that you need to remember to be able to do these problems. Okay, so here are two examples of that. We have the point -1, 1 first, and that is a rectangular point. It's an x, y, and we need to convert it to a polar point, an r theta. So I will need to know the r. So I'm going to start with the r squared formula. The r squared will equal the x squared plus the y squared. So in this case, -1 squared is 1, and 1 squared is 1, so 1 and 1 is 2, and r will be the square root of 2. You will also need the theta, so the tangent formula is going to help you get that. The tangent theta is your y over your x. So in other words, your tangent is -1. And you have to think about what theta would be that would give you a tangent of -1. And one of the possibilities from your unit circle is 3 pi over 4. And so your polar point for this -1, 1 would be the square root of 2, 3 pi over 4. And if you think about this -1, 1, that goes into the second quadrant, and this would also be in the second quadrant. For our second example, we have the point 0, 2. So again, I'm going to start with the radius. R squared is going to equal my x squared plus my y squared. So that's going to give me 4, and r will be 2. And then again, I'm going to do my tangent. Tangent theta is going to equal the y over the x, which means it's going to be undefined. And again, if you have your tangents memorized, as I suggested from your unit circle, then you'll realize that your theta, your angle, is pi over 2. So we have to go back and remember all that unit circle stuff again. So I have radius of 2, theta of pi over 2. Okay, now we are going to be moving into converting whole equations from polar equations to rectangular equations. And remember, with polar equations, we have things like r and theta in them, and rectangular has x's and y's. So our goal is to get rid of the r's and the thetas and to only have x's and y's in the new equation. If you're thinking you're done and you still have an r in it or you still have a theta in it, you're not quite done. Things that you can use are the formulas that I ask you to memorize, which would be r squared equals x squared plus y squared, tangent theta equals y over x, x equals r cosine theta, y equals r sine theta, and something that we haven't used up until this point is trig identities. So those trig identities that I ask you to memorize, they could come in handy now. Okay, I'm going to do several examples here of these equations because they vary in difficulty. The first one, r equals 2, we talked about yesterday. It would just, as a graph, be a circle with radius 2. And so if you center that at 0, 0, some of you could just figure out what the equation would be because you know how to do the equation of a circle. If not, you can fall back on that r squared equals x squared plus y squared formula and plug in your 2. And so 2 squared equals x squared plus y squared, or 4 equals x squared plus y squared. And again, that relates to our equation of a circle centered at 0, 0 with a radius of 2 that we did in our last unit. The second example, theta equals pi over 3, as we looked at yesterday, would be the graph of a line going through pi over 3. We have to use our formulas to figure out what that equation would be, though. So since we have this theta, I'm going to use that formula tangent theta equals y over x, because I can get y's and x's into my new equation using this. I'm going to go ahead and plug in that pi over 3. So tangent pi over 3 equals y over x. And then I know what that is from my unit circle. So the tangent of pi over 3 is square root of 3. And if you wanted to solve it for y, as we normally do for equations of lines, I would just multiply by x. So x times the square root of 3 equals y. And that would just be a line with a y-intercept of 0 and a slope of square root of 3. For the next one, this r equals secant theta, this is an example of when you would use a trig identity. And the first thing is, secant is 1 over cosine. So if I start by plugging that in, I still haven't got x's and y's in, but watch what happens when I multiply. If I multiply both sides by cosine theta, and it cancels out on this side, so I have 1. And I move the r to the front because it doesn't matter what order I multiply things in, I have r cosine theta equals 1. Well, r cosine theta is the same thing as x. So this equation is x equals 1. It's a vertical line going through 1. Okay, for example 4, we have r equals the cosecant of theta. And so none of your regular formulas that I ask you to memorize have the cosecant in them, so we're going to go with the trig identity and say that r equals 1 over sine theta, because cosecant is the same thing as 1 over sine. And this is similar to that last one where we're going to multiply by sine on both sides. And when you do that, these are going to cancel. And over here, I'm going to move the r to the front and have r sine theta equals 1. And r sine theta is the same thing as y. That does relate to one of the formulas. So this equation would be y equals 1. For example 5, it's a similar setup except we have a 2. So I'm going to replace the secant with 1 over cosine, or basically move it to the bottom and call it cosine, because that relationship, that trig identity, allows me to do that. And similar to the last problem, I'm going to multiply by cosine on both sides and cancel those out. And I have r cosine theta equals 2. And again, r cosine theta is the same as x. So I have x equals 2 as my equation. Again, that's a vertical line. And then for example 6, I have r equals 2 cosine theta. Well, it looks similar to number 5, except that it has a cosine instead of a secant. That actually changes this. This one is a really unique situation. The only way to get out of this one that I have found is to multiply both sides by r. If you multiply on this side by r times r is r squared. Here, I'm going to move the r in front of the cosine and have 2r cosine theta. So I have r squared equals 2, and then r cosine theta is the same thing as x. But I'm trying to get rid of any r's and thetas in this equation, so I need to get rid of the r squared as well. Luckily, I have a formula for it, x squared plus y squared. So I now have x squared plus y squared equals 2x. It only has x's and y's in there. So I'm down to a rectangular equation, and I can manipulate that any way I need to. I can solve it for y if I need to. Just depends on what I need in a multiple choice setting if that's the case. Otherwise, if you're just asked to get it to a rectangular form, you're there because your only variables are x's and y's. Okay, I have 2 more examples here that are a little bit more interesting than those last ones. For this first one, example 7, I'm going to multiply both sides by the denominator 1 plus sine theta. So I have r times 1 plus sine theta equals 2 once those are multiplied and canceled out. And here I want to distribute the r in. So r times 1 is r times sine theta is r sine theta. and that again equals 2. Well, r sine theta you know is y, so you know you're going to have plus y equals 2 here. But this r, if you wanted to think about some scratch work here, we know that r squared equals x squared plus y squared. So if you square rooted that, r would be the square root of x squared plus y squared. You can actually put that in for r. So the square root of x squared plus y squared. And that was just scratch work over here. Okay, that seems a little funny, but again, I mean, it's all in terms of x's and y's. There's no r's and no thetas, so it is a rectangular equation, and you could manipulate it and solve it for some different variables if you needed to. It might be a little challenging, but I'm going to leave it right here because I have gotten rid of the r's and the thetas. Example 8, I'm going to do that same approach. I'm going to multiply by the denominator. So r times 2 cosine theta minus 3 sine theta equals 6. And I'm going to distribute in. I'm going to have 2r cosine theta minus 3r sine theta equals 6. And again, r cosine theta is x, so I really have 2x. And r sine theta is y. So this becomes 3y. And I'm to a rectangular equation, and I can solve it for y if I needed to.